Boa tarde, personal. Mi nombre es Alejandro Caparelli, eu sou presidente de Rockwell Automation para a América Latina. Eu gosto muito deste país. Eu vim para este país de férias quando era menino, com meu pai, com minha mãe. Depois vim com meus amigos, vim com minha esposa. E agora continuo vindo por aspecto profissional com minha família, para gozar das melhores praias do mundo. Mas toda essa experiência serviu para desarrollar, em meu caso, um portunhol. Realmente não sou um experto em português. Então, respeito para as pessoas que falam português e para que todo mundo entenda, eu vou trocar e vou mudar para falar em inglês. Okay? So, good afternoon, everybody. First of all, I would like to thank for the authority to really invite Rockwell Automation to participate on this amazing event. Really, I spent basically a day and a half, 2 days, on an amazing organization, as well as an amazing spirit about the event in terms of the innovation and so on and that. What I'm going to be covering today is going to be the high-level presentation in terms about the whole transformation process that is around the world based on the digital transformation, and particularly how Rockwell Automation, based on the connected enterprise, are going to be enable the companies in go through this process. First of all, when we're talking about digital transformation, what do we need to do is we need to start to conceptualize what really does it mean. And the best way to do that is just to identify a couple of significant trends that is going to happen into the future. During the last day, we're discussing about how everything is increasing exponentially. I mean, based on the information that we have, I mean, the amount of the devices that are going to be connected to the internet basically is going to be 3 times compared with what we do have today in the next 4 years. Definitely going to be moving from the 50 billion, 15 billion devices connected today into the internet to the 50 billion, 50. So as you can see, that's going to be a tremendous increase. The second one, and this is a relevant trend that we see in the future, is about the collaborative environment that's going to happen, working together robots and people, side by side, in a very collaborative environment. The next one is related about the capability that the system is going to be to develop based on artificial intelligence in order to create model and anticipate events before those happens. That's going to be very positive in order to take the right decision at the right time, maximizing the production at the shop floor. And finally, it's related about the mobility and how the mobility is going to have impact on the workflow that we have into the production process today. I mean, this mobility is going to be tied with the real-time information, and it's going to be extending the activity beyond of the plant floor. Now, continue moving forward. I think that mostly of you've been listening during these days about the cloud, artificial intelligence, Internet of Things, Industry 4.0. And I mean, all of this, that means that it's going to be the next wave of opportunity for the company to create productivity, as well at the same time, in many of those cases, it's going to be change and create an opportunity in order to create generate new revenue streams on that. Basically, all those concepts are very well understood by the leader of the company worldwide. As you can see there on the screen, 87% of the leaders, they understand that it's going to have a significant impact into the production process. But I mean, that's going to be at the same time presenting a challenge. And the challenge is like today, there is an estimation that only 7% of those companies have a specific plan and a specific strategy in order to take advantage about this technology or this digital transformation that happened. And after that, enjoying the benefit that we were talking before. When we start to narrow all this digital transformation into the industrial environment, we'll see that it's going to be about more than 5 billion devices of the devices that today are into the industry that are going to be connected into the internet. This is going to happen, and it's going to have a significant impact in terms of that generate a strong communication process, a strong platform, but also at the same time, because all the costs related about that is going to be continue decreasing. And what is the most interesting about that? The cost of the computing is going to be decreasing, the cost of the communication is going to be decreasing, but also the cost of the sensing process is going to be decreasing. And this is the time when it starts to be enabled about the big data into the shop floor, okay? Because as you see, what happened into the manufacturing process, all the data is generated based on instrumentation or sensing capability, as well into the control capacity of that. We, as a Rockwell Automation, we developed a strategy and a platform that we call the connected enterprise, o la empresa conectada. Basically, the connected enterprise, what does it do? Basically, it enhances the industrial Internet of Things into the production environment, with a positive impact into the production level, into the productivity, but also at the same time in order to increase the competitiveness of the company. What is interesting that when we're talking about the competitiveness, more and more, it's not the competitor that you have in your town, it's not the competitor that you have in the state, neither in the country. As you realize, moving forward, this world is going to become smaller and smaller, so really you need to keep the perspective about how you're going to be competing with the vendor or some other company that maybe is not going to be located even in your country. The connected enterprise offers the possibility in order to get all the data basically transferring free, transparent across the plant. Also at the same time, connect the smart devices, where those smart devices are going to be giving you the capability about what is the status of the production process, but also at the same time, what is the status of the own devices in order to really need to generate some kind of maintenance activity and so on that. At the same time, I mean, all this analytic aggregating about the data that we're talking about that, this is the time that we start to get this information is an actionable item. When we're talking about the connected enterprise, this is a journey, okay? And this journey starts basically to understanding about what is the industry needs, but also at the same time, what is application need that they have in that specific industry. After that, I mean, we need to combine the resources that we have in terms of talent, in terms of technology, software, as well and consider about the ecosystem in order to have the best definition with the customer about what is the best opportunity to generate productivity for the customer. At the end, everything should happen into the simplified environment. As you know, by default, simplification basically means productivity. And this is all about when you're thinking about in terms of the production. When I was talking about the connected enterprise, this connected enterprise is basically on the high-performance architecture, which is basically the devices that are connected at the shop floor. This device is going to be allowed just to interconnect the information from the shop floor up to the administration level in order to operationalize the information, in order to analyze the information, and take the right strategy about that. All this information based on smart devices is going to be aggregated, okay, in order to get the right decision. Now, when we're talking about technical projects or we're talking about digital transformation, it's very important to keep in mind that any kind of effort that we're doing in that sense really should be looking for some kind of a realistic, productive environment that really is going to bring the benefit of that. Some of the examples about that in terms of this connected enterprise benefit that it's going to bring for the industry is about, for example, the track and trace capability that is used in the life science, or in some other cases they call the serialization process. Another example that it could happen into the consumer space is about just to have more machine available, more uptime in order to continue producing more. When we're talking about the oil and gas industry, it's about how we optimize the process that we extract oil from the field. And in terms of the mining, for example, just to give you another example, it's basically about how we can increase the yield of the mining process in terms of just to increase the productivity for the company. So again, as I mentioned to you, I mean, one of the really advice that I would like to share with the team here in terms of the entrepreneurship environment, that any kind of technical development that we're doing that is very important that really we have as a goal a specific impact. When we're talking about the impact, it's going to be about the competitiveness, it's going to be about the productivity for the company, otherwise it's not going to be sustainable in the long term. At the end, all this high-performance architecture is going to be able to basically contextualize all the information, aggregate that in order to create a specific information to really address a specific action at the plant. So really, this is the time where we're basically connecting all the data from the field, contextualize that in order to increase into the value proposition, and at the same time also create a specific action for the industry. Also, all this should be happening into the secure environment. Yesterday, it was mentioned here on the Congress, and also was reading on the news about the different attacks that happen day by day. So security is one of the aspects that should be considered at the time that we're talking about digital transformation. Digital transformation brings all the benefit that we're talking about that, but also at the same time, we need to make sure that we're going to be conducting that into the safe environment. Now, talking with different customers around the world, we start to have a discussion to see about where the areas where the customer, they see the highest opportunity of return on investment for this digital transformation or implement about the connected enterprise in their show floor. First of all, it's talking about the smart asset. And when we're talking about the smart asset, we can talk about smart asset, the smart machine, smart manufacturing, where at the same time is providing much more information in real time in order to take the best decision in the production process. The second is related about the predictive capabilities that the machine, the assets, are going to be generating. Those predictive capabilities, basically the impact they're going to have is going to be more time available to run those machines or those devices in order to avoid the basically downtime that is not really scheduled at the plant. Moving forward, with all the data and all the information, you're going to be supporting the company in order to comply with the local requirements. Those requirements could be from the government in terms of the quality, or it could be also from the labor standpoint of view. For example, I was discussing with you in terms of the quality about all the track and trace capability in the life science that also apply into the food and beverage in order to understand about when this device was generated and also what is basically all the story that is behind of this. Finally, all this, the connected enterprise platforms, is going to be able to generate a better vision about the supply chain process, which is along the whole productivity process that is going to happen into the manufacturing environment. Now, those are the specific areas what I was mentioning to you in terms of what are the specific areas that really they see an opportunity to improve the return on investment. But at the end, what really does it mean for the company, for the industry? And that means a couple of things. First of all, is the capability to increase, basically, or actually reduce the time to market of the products. This time to market to the product could be happen in terms of the new products that they want to launch to the market, but also at the same time, change the configuration between one production to the next production in order to reduce those downtime and going faster into the market. There is an obvious advantage about how it's going to be the positive impact for the company on that. The second is just to reduce the total cost of ownership. Total cost of ownership means about how much money the company they need to spend in order to maintain the equipment up and running. That could happen based on maintenance, also could happen based on upgrades or updates that they need to be happen. If we remember, I mean, in terms of the diagnostic capability and with all the information that we're going to be collecting from the smart asset, I mean, that's going to give us an opportunity to really understand about when do we need to interact with the smart device or when do we need to interact with the machine in order to be very effective instead of just to wait until that is get broken or until basically just to do some activity that is not really required. The next one is about basically improve the asset utilization. And again, this is a concept that is related about just to keeping all these assets that the company made an investment in terms of the CapEx in order to continue up and running, in order to produce more, basically on the different shifts. And the last one is just to do the risk management across the entire company based on all the data that they're capturing this. This is going to be possible based on the capability of the control system, where this system should be scalable in terms of the control capability, as well on the analytic capability. So this is a very interesting concept because when we're not talking about here the large plant or the huge installation. I mean, when we're talking about scalability, that could apply for the small manufacturing production area, medium or large size. The next one is related about all the influence about the mobility and the collaboration that generates. Keep in mind about that, I mean, with the mobility, I mean, in the way that we're working today and we're interacting with the machine, it's not only happening inside of the company, but also it's going to happen outside of the company, especially where we enable this company in order to have the connected services, but also at the same time, how do we involve the ecosystem in this production process? At the end, I mean, this is what you can see on the slide on the bottom. It's basically the platform, technology platform that we provide through the connected enterprise to basically enable you in all those levels that we're discussing about. As I mentioned to you, mobility and collaboration is going to be, actually is a big deal for the companies. Collaboration and mobility, I mean, thinking about that, I mean, we can think about that, I mean, at the beginning start with some kind of a personal issue or personal needs in terms of okay, let's manage the email. After that, that was extended to the office environment. But now, I mean, what do we see? That, I mean, that's going to be clear defined and extended to the industrial production environment as well. This means that, I mean, for every smartphone that we have, we're going to have the capability to get the data in real time, but also at the same time having information in order to take the right decision on that. So you see that, I mean, this is providing an opportunity to really not interact inside of the company or inside of the plant, but also at the same time to extend that into the collaborative environment with the ecosystem. As I mentioned to you, basically, the connected enterprise is going to be a journey, okay? It's going to be a journey that basically is going to have this relevant step that I'm showing to you right now. First of all, is identify what is the opportunity that we have in order to create this productivity or competitiveness impact into the production. How we use this technology in order to have a really specific outcome, a positive outcome into the production level. The second is about how do we create the alignment in terms of the technology standpoint of view, but also in terms of the organization standpoint of view. And the last one is just to implement about that. But until now, we're discussing about technology. But this is not just about technology. It's also about the people, right? It's about how these people, they need to basically develop a new skill to work in the new, basically, workflow that is going to be generating all this digital transformation. But also what is important, that is talking about organizational change, which, as you know, I mean, those organizational changes are basically where I really require a lot of effort in order to basically move things that we've been doing for many years now to the new environment that we're having today. So as you can see, I mean, this is a big effort that, I mean, from the technology standpoint of view, today we have the platform, we have the technology, the devices, the smart devices to do that, but also at the same time, that's going to be effective at the same time that we develop our talent to the level to develop, to manage that, and also at the same time in the way that we operate versus on our organization. Saying that, what I would like to share with you is basically a website where those persons that are interested to understand a little more about the connected enterprise, about how the digital transformation is going to be impacting into the production environment, you can go and take a look about that and gather most information. Thank you very much. Mucho obrigado.
Boa tarde. In Texas, we say howdy. Howdy.
We're engineers.
Howdy. Good. This is to wake up because after lunch it is difficult to stay awake. Even though we talk about innovation, innovation comes with creative minds which are alert. Thank you very much for this opportunity. As an educator from Texas A&M, I have been coming to Brazil for many years. We brought students from engineering in different cities, in Campinas, in Rio de Janeiro, in São Paulo, and Florianopolis, and Salvador. So we have been to many places in Brazil, and this connectivity of the educational systems and the minds is a key ingredient for innovation. I will say a few things about the transportation system since my colleague covered the autonomy in relation to the factory. So I will focus on transportation systems, and this is one of our focus areas at Texas A&M. It is one of the big universities in the state of Texas and also in the United States. Very similar to some of the universities you have here, like USP or Unicambi. And many students now, we're 60,000 students, and about 20,000 of those are in the engineering school. As a complex organization, we have the academic environment, the School of Engineering, but also we have state agencies that promote research and development. The experiment station that was established about 100 years ago with the Industrial Revolution, when transportation became an issue with automobiles, and then we have the Transportation Institute dedicated to that, plus the training, the extension service. And as I was thinking about transportation, the departments we have that educate our students are the classical departments that we see everywhere. But if you think about transportation, it's relevant in each one of those. aerospace engineering, aerospace vehicles, civil engineering with the connected infrastructure. You have agricultural engineering with think about biofuels and precision agriculture, and I will say something about it. Of course, mechanical engineering with the automotive industry, ocean engineering that has the autonomous vehicles now, the underwater vehicles, even biomedical engineering with the autonomous robots that travel through the human body, the micro robots for microsurgeries and capturing pathogens. You can think of this as an autonomous transportation system. Let me say that currently the autonomy in transportation, you can think of this as in ground vehicles, but also in aerial vehicles. Of course, the aircraft industry is a good example of autonomous systems, but the more the UAVs, the unpiloted aircraft, small ones, are everywhere, transporting goods and services as well. Of course, in the water, we have the big boats, but we have the underwater vehicles. And then space transportation is being commercialized with many countries. Brazil is focusing on space, as well as many other countries in the world. As we improve technology, you see in the vertical axis is how accurate we get, and with time, we become much more accurate and reliable in developing technologies. And then before it is not too long, like in a few years, we will see semi-autonomous driving. Already many test beds have been testing the different systems, and you can buy cars that are ready to be driving autonomously. And the estimate is that before 2025, we'll have also fully driving, autonomously driving systems on the highways. One of the key ingredients is the psychology of autonomous systems. And as an example, this is a picture of our Texas A&M University campus. We have instrumented several vehicles, like you see, one is a regular car, the white one, the middle one is a small car, and then a pickup truck that you see at the other corner, which is basically the evolution of the horse, the cowboys with horses that now use pickup trucks, a very integral part of the society, and they're connected to it. So how do you let them be autonomous? It is a big part that psychology is playing, and we have several autonomous vehicles at Texas A&M campus, so we can get used to interface with them. One area that we're building with our Transportation Institute is platooning of big trucks. If you have a big truck that transports goods on the highway, about 65% of the energy you spend is to fight against drag, because it has a big profile, aerodynamic profile. If you do platooning, and this you can see actually sometimes flying birds, the formation flight, they do this because they save energy. And if you, with autonomous driving, all you need in this case is to have one pilot, one driver in the front, and then the cars form in this formation transportation, they go as a platoon together, and then all you need is one driver. The others can be close together because sensor technologies have been developed. And by doing this, you have safer transportation, but also more economical, because you can save up to 20% in fuel consumption by having this formation transportation, this platooning. This is something that we're actively investigating, and we have experiments with the Texas Transportation Institute. Another system that we have developed is this freight shuttle, which basically is like a robot that moves on a rail, goes to a port. As goods arrive here, let's say in Brazil, in Rio de Janeiro, or in Santos, or in Salvador, Florianopolis, many of the cities you have, then an autonomous system can pick up the goods and transport them. In this case, it is on rail, but you can think this also transportation on a river, like Amazon River or other places, you need to develop the sensors to do that, and then the safety in the transportation. You save, of course, in handling the logistically becomes a much more efficient system, not just the transportation aspect of it. And then, of course, you have to think of the highways, either the actual concrete or asphalt highways or water systems that need to have pointers and communicate with the vehicle. And this could be as innovation can come from smart paints, for example, that can communicate with the vehicle and channel it into the right direction. We have an agreement with Tesla to develop further these smart highways. When it comes to the aerial vehicles, of course, many of the big aerospace companies, Embraer, Boeing, and others, Airbus, they are developing, of course, the autopilots for years for safe landing and takeoff. But the small UAVs, think of those to be used for precision agriculture. This is going to be, and it's happening as a big innovation because you can use it for many causes, not just to look images, but to do data analytics and decide if it is time to fertilize or do other things, harvest the crops. And then you see the tractor now that there is no place for the driver. You can see a big engine. I mean, it is a big engine, and then you can see the wheels. And then it is an autonomous system. It's a robot that moves and does the needs of the farming. And as I mentioned, this is a program we have actively for several years now, where we send small airplanes, small UAVs, and they have sensors for temperature, humidity, soil moisture, and then they decide about if it is time to do fertilizing or harvesting of the crops. Or also, in some cases, you deal with pesticides, with things that are harmful for the human, and then having a UAV delivering it, it is much more efficient, and of course, from the health much healthier, and you can deploy these robots instead of humans piloting this aircraft. If we go, especially for the oil and gas industry, the immediate need is for underwater vehicles that can operate at deeper depths below sea level, and they can operate at high pressure, the harsh environments of deep sea exploration with safety and reliability. So many of these projects, the offshore technology platforms, can be established cost effectively. And there are autonomous systems. One is outside on display, and many countries, Brazil is a key creator of some of these systems as well. Now, I want to say in the final few minutes some of the activities that can happen in a university environment. This is a call that we had from SpaceX to develop a new transportation system that is called the Hyperloop. And if we can play, there is a YouTube video. Can we play it, please?
We're engineers. Our way of reaching for the future is to take on the toughest problems and to find creative and innovative solutions. With Hyperloop, SpaceX has thrown down the gauntlet, and we have accepted the challenge.
At Texas A&M University, we're going to be hosting the Hyperloop competition. This will involve tons of different teams, some from all over the world.
The Hyperloop is a conceptual vehicle that will go inside a low-pressure tube that will be able to send people between cities at high speeds. The lighter it is, the easier it is to make it go as fast as possible, and that's another design goal in this project.
What we had to do was create an iterative design process. We set a systems management team so that they could really pull everything together.
It's one of the top engineering and technology institutions in the United States of America. Texas A&M is the perfect place to host a competition that is all about igniting groundbreaking ideas and encouraging young minds to solve some of the critical challenges we will face in the future.
This isn't something that comes around all the time. Not everyone gets this opportunity. We've been able to accomplish things I never thought we'd be able to. It's just been a great experience.
Thank you. And you can find on YouTube other videos. This competition started with 120 teams coming from all parts of the world. I don't think we had any Brazilian teams, but there is still time to go into the next phase of the competition. So after the initial designs, then at the headquarters of SpaceX in California, there is a test track that you can put your original design for testing under certain conditions, basically how fast you can go, how you can brake safely, and how you can go in a tube that has lower pressure with fast velocities. So this is an ongoing project that maybe in a few years, the few winning teams, and we had several from Europe, Asia, and the North America that have been able to move forward for the next phase of the competition. So that is a new transportation system that we may see within our lifetimes taking off. Other activities we do that motivate students is what we call the Aggie Challenge. We give grand challenges to our students, and then they work with mentors from industry, some national labs, and they find solutions. For example, this is a case of a virtual reality space environment for transportation to space and living quarters in space that we have developed jointly with NASA. And Aggie's Invent is a very fast-paced environment where students get together for 2 days, 48 hours. We just provide food to them, and they don't sleep basically for 2 hours, for 2 days, 48 hours, trying to develop a solution to a problem that we give them. And there are several: transportation, autonomy, manufacturing, space, medical devices, and students love it. As you can see, we have already developed 18 events of more than 800 students, and there is a big demand for this effort. And finally, I want to close saying that we have put together our resources, the Texas A&M University system, and we took an old airport, basically, that was given to us by the government, and we're trying to make a smart city. Basically, there will be all the test beds for autonomous vehicles, but also industry, university collaboration. We're building, as we speak, one big center. We call it Center for Infrastructure Renewal, where not just the structure, but the distribution, the smart grid, the autonomous vehicles, but also water, and as I mentioned, the energy will all be connected and tested in a unified environment. And also part of this smart city collaboration will be an autonomous systems laboratory that will have, from test beds for testing autonomous systems, also human machine interfaces, and will be part of this smart city environment. So these are some of the activities we're pursuing, and we hope that this fusion of creativity that goes into developing autonomous systems will bring us together, and we will continue moving forward with innovation. Obrigado.